Hi, I am Otanu. This is the series of the tutorial video of the class 9 mathematics. Here you learn from basic to advanced level. If you watch the entire video from the playlist, you will able to start your exercise yourself. I also take online class for more doubt clearance and one-to-one communication also, and take test and prepare for the advanced level. I advise you to complete the entire video till end, and you should take note also when you watch any of this video before apply your concept to do exercise from any of your textbook. This is my effort to make the quality affordable education to everyone. So please share this video with your friends and like this video, subscribe my channel and press the bell icon so that you get notification when I will update any video. So let's get started. Hi, I am Otanu. In this tutorial video, you learn about the polynomials. The polynomials, we should know the following terms. So let's take one example, that is later we learn why this is the polynomial. Okay, so what are the conditions that should be satisfied to become a polynomial? Before that, we should know about the different terms. Clear? It is the component of the polynomials that value do not change, so it is the constant. So for example, the above example, the constant are 6 and -5, 6, 6, -5, 2, -12, because this value do not change here, so this is the constant. Okay, next we learn the variables. What are those variables? So variables are the part of the component of the polynomials that value change. It is not the constant. So for example, here the x is variable. Clear? So next we learn the what is terms. So term is actually the combination of the combination of four things, that is the variables, or you can say first is sign, next is the numbers, next is the variable, and then next is the power. Okay, so these are the four component combined together, they are the terms, and each term is separated by the plus minus. Okay, each term separated by plus or minus. Okay, is it clear? So this above example, what are those terms? So 6x cube is a term, -5x square is a term, 2x is term, -12. So this is the there are four terms in this above example. Okay, clear? This above example, there is a four terms. Okay, and so look at this of this example for -5x square. This is sine. Okay, this is sine, and this is the constant part. This is x is the variable, and this is the power. These four things combined together is a term. Clear? So if I told you that, suppose another example, that is, for example, 2x minus root 3 root 3 2x cube minus root 3x plus 1. So here what are those terms? Here terms are 2x cube is a one term, another is minus root 3x terms, and another is the 1. This is also a term. Clear? This is the another example. Okay. So terms are further classified into two, that is like terms and the unlike terms. So what are those like terms? Like terms actually the terms which having the variable with the same power. So let's take one example of the like term, variable with the same power. So this is example is for 2x square root 2x square. These are the like terms. Okay, these are the like terms. Another group I can give you the example, that is 2 by 7x and 1 is x, for example. Look at this. Here the power is actually the same. This power with the variable is same. Clear? The power of this variable is same. Here also x, when the variables are the same, then you can say it is the like terms. Okay, clear? So what is unlike terms? The unlike terms are those terms that having the different variables with its power. And variables can be same, but the power is different. For example, if I told you the example for 2x and minus root 2 x square. So these are the unlike term. Why? Because this x and x square, these are the variable. This variable is x, but the power is different. That is the reason. But what is happening here? Here the variable is x as well as the power is the same. So these are the example of the unlike terms. And also you can say that for example, if I told you 2a and 3b, these are also unlike terms because variable itself is different. We know the variable is represented by the alphabets, English alphabet, and here the variable is itself is different. So these are also the unlike terms. And here also you must remember, if we change the variable, for example, with the same power, for example 2x square and root 2 y square, also power is same, but here the power is same, correct, but the variable itself is defined with different alphabets. So variable is the different. So these are the these are the what these are the unlike terms. It is not the like terms. Okay, this is not the example of the like term. This is actually the example of the unlike term. Why? Because the power, although the power is same, but the variable itself is different. Okay, clear? So you can easily identify in the polynomials which terms are the likely terms and which terms are the unlikely terms. Why it is so important? Actually we learn in the operation of the polynomials, there only subtraction, addition, all these things we do in the like terms only, otherwise it will be not possible. That is the reason we should have the clear idea about the like terms and the unlike terms. Is it clear? Okay. Next we learn the coefficient of terms. So suppose the above example, this example, what are the coefficient? Coefficient actually 6x cube. This is the terms we already learned, that 6x cube is the term, minus 5x square is the term, and also 2x term and minus 12 is the term. So here the coefficient of the term 6x cube, actually the 6, the constant part with the sign here. So 6x cube, this example. So here we take one copy here. So in this example, the coefficient of this term, so first you identify the term. So term is what? 6x cube, and here you write down the coefficient. Right side you write down the coefficient. So the terms 6x cube, this term coefficient is what? Is actually the 6. And again the coefficient of the minus x square, this term, the coefficient of this term is actually what? Minus 5. And 2x, the coefficient of the term 2x is actually the 2. Clear? And the coefficient of the last term, that is minus 12, is what? So stop it. Since this part is actually this is minus 5 and this is 2, and this is the constant part, so having the no coefficient. Clear? Since minus 12 is definitely, it is a term, but it is the constant term, there is no variable. So what is the coefficient of the terms? It is the coefficient of what? Coefficient of the entire variables. Okay, that means the constant term with the sign is actually the coefficient of the terms. Clear? So but we should have the clear idea of coefficient. Okay, of the coefficient, we should have the clear idea, the definition of the coefficient. The coefficient is the multiplicative factor in terms of polynomials in series, okay, or expression. Clear? Polynomial, a series or an expression. So let's take another example, that is, if I told you that is 5 and with a different color, we take the different color, x square minus 5x square minus 5x square, okay, and then we write as plus root 2 x, and not take x, it is considered as y, okay, and then I consider another is actually the 2. So here you should have clear idea that which part is actually the coefficient. So this is the coefficient, and this is also coefficient. This is also the coefficient, include the sign and the constant part of this term, and this is the variable, this is the constant. Clear? This part is constant. So if I told you another example, that what is the coefficient of some variable, then so let's take one example, that is minus 5x square y. So what is the coefficient of, if I told you what is the coefficient of y? Coefficient variable y, then the answer will be, so from this definition, coefficient is the multiplicative factor, means in these terms, how many factors are there? You can simplify to get the different factor, that is 5 into x into x into y. So you get the different factor. For example, factor means what? Can divisible by this any number. Means if we divide this entire terms with the minus 5, you get the quotient as x square y. So that part is actually the coefficient of the minus 5. Or if I told you what is the coefficient of the y, then what is remain part? Minus 5x into x, that is minus 5x square. So here the coefficient of the variable y would be what? Would be minus 5x square. This is the right answer. Clear? And if I told you again the coefficient of x square will be what? Minus 5y. If I told you coefficient of x square y will be what? Minus 5. Clear? Is it clear? So this is the general concept of the coefficient. Now what is leading coefficient? To find out the leading coefficient of any polynomials, first, for example, one polynomial given 3x plus root 2x square plus 1. Clear? What you have to do? You have to write the standard form. Later we discuss what is the standard form of the polynomials, so that you have clear idea. But since we are discussing the coefficient, so you should have the clear the different terms and details understanding of the coefficient. Clear? So what you have to do? You have to arrange into the power descending order. Now ascending order, anything you can do, but the ascending order or the descending order. So here I just arrange it as the descending order. That is, first the highest power, then it is 3x, then it is 1. So this is the actually the leading coefficient, because this is the lead, means the starting the standard form. Okay. So which the order of the polynomials we learn later, means the highest power of the variable. Clear? So this is actually the, this part means root 2 is the leading coefficient. Leading coefficient of this polynomials. Clear? Next we learn the algebraic expression. So what is algebraic expression? So when the different terms separated by the plus or minus sign, then we can say it is the algebraic expression. Clear? So we can say that this expression is actually the algebraic, this polynomial is actually the algebraic expression. Clear? Why? Because this is one term, this is second term, third term, fourth term. This all term is separated by plus and minus. So every polynomial is a algebraic expression. Clear? Next we learn the polynomials and types. So here earlier discussion we have learned that what is algebraic expression. Polynomial is a algebraic expression, but all algebraic expression is not the polynomial. So we should have the clear idea what are those polynomial. So I give you example, that is if I told you that is this example, why this is polynomial 6x cube 6, this is a polynomial definitely. Why? Because you must remember this is the algebraic expression, and the variable, this variable power should be the whole number. Power is whole number. The variable power always, all variable, this one also, this one also. Clear? You must remember, if the variable power is not the whole number, then you can't say this is a polynomial. For example, if I told you that is it the polynomial, for example, 2y minus 2 to the power minus y, 2 to the power uh, 2 y to the power root 2 y to the power minus 1, or you can express it as the minus root 2 by y. You can say this is the algebraic, this is definitely algebraic expression, but you can say it is a polynomial, although having the variable constant and power is there. But look at this, look at this term minus 1. So minus 1 is not a whole number. Clear? So this was the polynomial, but this is not polynomial. Clear? This is not polynomial, not polynomial. Clear? You can't say this is the polynomial, because having the, I can give you the more example. Give them more example. Just a minute. So another example is 3 root x minus 2. Is it the polynomial? No, it is not the polynomial. Why? Because here the we can write the given expression as x to the power minus 2, or minus x to the power half. Clear? Minus 2. So this is not the whole number. Okay, not the whole number. So this example not polynomial. Hope you can easily identify which algebraic expression is polynomial or not. Clear? Next we learn the type of polynomials. The polynomials are classified based on the number of terms. The polynomial can be classified as monomial, binomial, trinomials, multinomials, and the zero polynomials. So what are those? Let's take one example each, one or two example each. First is monomials. Monomials means the having the only one terms. Clear? Having the only one term. Or if I told you 3x square, this is a polynomials and having the one term. Root 2 y, this is also having the one term. Okay, this is the monomial. What is binomial? Binomial actually having the two terms. If I told you 2x square plus 9 and 4y cube plus y. So having the two terms. Trinomials 3x cube plus root 2x square plus x. So this is the example of the trinomial having the three terms. Multinomials more than three terms. For example, 7x to the power 4 minus 2x cube plus root 2x square plus x. So this having the, how many terms are there? 1 2 3 4, and if you write another terms, that is 2, then you can say it is more than three terms, so it is a multinomial. So what is zero polynomial? Zero polynomial means the is the neither monomial, binomial, trinomial, only the zero, means the value is zero. Okay, if the value is 0, then you can say value of this entire polynomial is 0, then you can say it is the zero polynomial, means there is no variables. Okay, clear? Or you can say that if the constant, all the constant part is 0, that is 0x square plus 0x, okay, plus 0. So this is actually the entire value is 0. So this is called the zero polynomial. Clear? One thing you also remember, that is, if I write down any constant, for example, if I told you 3 by 5, so this is also a monomial. Okay, this is also a monomial. Okay, because each individual constant itself is a monomial. Okay, before classify the polynomial based on degree, uh, we should have a clear idea about the standard form of polynomial. Okay, and one, what is degree. So first we learn what is the standard form. If I told you some if I told you uh, if I told you that uh, uh, let's one example, uh, is this polynomial isn't standard form, 3x square 3x minus 2x cube minus root 2x 4 x to the 4 plus x square plus 1. No, it is not the standard form, because the power of this variable not in ascending or the descending order. So first we have to arrange either ascending order or the descending order. Clear? So either we can write as minus root 2 x to the power 4 minus 2x cube plus 3x plus uh, 3x. Okay, no, sorry. So minus 2x cube plus x square plus 3x plus 1, we arrange it the power descending order. Okay, so this is a from the higher power to the lower power. Okay, so it is the standard form, or you can write as 1 plus 3x plus x square minus 2x cube. Okay, 2x cube minus root 2x to the 4. So these both are the standard form. Clear? Both are the clear. These both are the standard form. Okay, so these both are the standard form of this given polynomials. Both are the standard form. Either you can arrange in the ascending or the descending order or ascending order of the variable based on the power, variable power. Okay, so you can do that. So next we learn the degree of the polynomial. So this above expression, the highest power, that is x to the power 4, that is what is the highest power? That is 4. So 4 is the 4 is the uh, 4 is the degree of above polynomial. Means you have to find out the what is the highest power of the variable, that is x to the power 4. So degree of this polynomial is actually the 4. Clear? Okay. Now we get idea the standard form as well as the degree of the polynomial. So based on this degree of the polynomial, we can classify the polynomial as below. If the degree is 0, then we can say it is the constant polynomial. So for example, if I told you root 2, this is the constant polynomial. 3, okay, this is the constant polynomial. 7, okay, because here the any variable power is what? Power is 0. Okay, so power is 0. Variable power is 0. Power is 0. Because x to the power 0 is equal to what? 1. Something power to the power 0 is equal to value is 1. Clear? So what are those linear polynomial? Linear polynomial can be generally expressed as ax plus b. Okay, ax plus b. This form you can express it, and where you must remember the coefficient of the x term cannot be 0, because if it is 0, not equal to 0, this is the condition. This is the condition. If it is 0, then it become the constant polynomial, not the linear polynomial. So linear polynomial means the degree actually 1. Degree 1. Clear? The maximum power of the variable is actually the 1. Clear? Next we learn. So next is quadratic polynomial. So before that we can take example of the linear polynomial also. That is, for example, root 2 x square plus x, or sorry, it is not the x square, it is x. The maximum power is what? 1. Root x square, root 2x plus 3. Okay, and also 3x also. 3x also. With variable is 0, it is not matter, but matter is highest power should be the 1. This highest power should be the 1. Remember it. This is the highest power should be the 1. Then quadratic polynomial example. Before that we should know the general expression of the quadratic polynomial, that is ax square plus bx plus c, where the a cannot be not equal to 0, b can be 0. For example, if I told you 5x square minus 3x plus 2, this is the quadratic. And if I told you 3x square minus 1, this is also a quadratic, because only consider that the degree of the two, that that part coefficient should not be the 0. Clear? Means 3, this cannot be the 0, this cannot be the 0. Okay, clear? Okay, next is, that is cubic polynomial. So quadratic polynomial degree is what? Degree 2. Okay, degree of the polynomial is 2. For the cubic polynomial, how you can express the general expression? You can write as ax cube plus bx square plus cx plus cx plus d, where the a cannot be 0, because the degree means what? 3. Cubic means 3, degree is 3. So this coefficient means a cannot be the 0. Okay, so let's take example, that is 7x square, sorry, 7x cube, 7x cube plus 3x square plus 2, because other variable term is not is so important, but the degree, that is 3, is important. See, do the coefficient of this uh, maximum power terms actually should be the non-zero term, non-zero number. Okay, here a is what, 7, so we can say this is the cubic polynomial. Okay, so for the cubic polynomials, the degree is actually what, 3. Clear? And next is the biquadratic polynomials. So biquadratic polynomials is actually the degree 4, degree 4. So we can take example, uh, general expression, or you simply take the example, that is uh, 5x4 plus 3x square plus 2x plus 1. So here degree is what, degree is 4. So only you have to consider the highest degree, highest power. So rest number is not the important, rest term is not important. So 5 should not be the 0, this should not be the 0, remember it. Clear? So then we can say it is the biquadratic polynomials. This is the end of the first part of the polynomial chapter. So see you in the next video. Thank you.